So in this video, we're going to be talking about potential energy. Potential energy is one of the few forms of energy that we're going to be learning about in this class. Potential energy is basically where you're understanding that an object can store energy as the result. So this video is going to be about potential energy, which is one of the few energies that we're going to learn about in this class. And so what you need to know about potential energy is that an object can actually store energy as the result of its position, so like where it's located. And potential energy is going to be the stored energy of position that's possessed by an object. So for example, a drawn bow and arrow has potential energy. You can see based on its position where the string is pulled back and the arrow is with it, it has the potential to then have other forms of energy based on its current position. If the bow was merely, I can't draw a bow, but if the string and the bow were sort of side by side and it was relaxed, this looks like a horrible bow. Anyway, it would have less potential energy than when it is drawn like this. Potential energy comes in two main forms. Gravitational potential energy, which is going to be the big one that we're going to be using in class, and then elastic potential energy. Gravitational potential energy is going to be the energy stored in an object as the result of its vertical position or height. So for example here, as the car goes up the hill, it increases in potential energy, and its maximum potential energy is achieved when it is at the top of the hill because it is at its highest point. And if it were to go down the hill, then it would decrease in potential energy. So here we could say that we have an increase in potential energy, and here we have a decrease in potential energy. Gravitational potential energy is a direct relationship between the gravitational potential energy of an object and the mass of an object. So there's a direct relationship there. More mass equals more gravitational potential energy. So another way I would write that is greater mass equals greater gravitational potential energy. And so here we have two items. They're at the exact same height. So in both cases we might have like a height of h. But here the one on the left is a 10-gram mass, and the other one is a 100-gram mass, and so therefore the one on the right over here will have more gravitational potential energy than the one on the left. Also, in gravitational potential energy, there's a direct relationship between that and the height of an object, as sort of implied a couple slides ago here. The more height, so an increase in height, is going to also increase gravitational potential energy. And so in this scenario we have two masses, and they're the exact same mass. Notice that they're both 10 grams, but the one on the right here is at a larger height and therefore has greater gravitational potential energy. And so this is all sort of leading up to an equation for gravitational potential energy. And we will represent that as it is shown here, capital P-E and then the subscript grav, or capital P-E with a lowercase g sometimes. And gravitational potential energy is calculated using mass times gravity times height. So here, gravitational potential energy is measured in joules, which we've already seen with work. Mass we know should be measured in kilograms. G is going to be the gravitational field strength, so we have that as 9.8. It's a different than the acceleration due to gravity, especially in terms of its units, which you might remember are meters per square second. Here we're using newtons per kilograms on Earth, and then h will be height, and that'll be in meters. So you need to watch all of your units here. The other type of potential energy that we'll talk about is elastic potential energy. Elastic potential energy is going to be the energy stored in elastic materials as the result of either their stretching or compressing. So like rubber bands will have elastic potential energy, as well as bungee cords, trampoline springs, the arrow that's in a bow that was used beforehand, etc. And of course, the amount of elastic potential energy is related to the amount of stretch that device has. So more stretch equals greater stored energy. And that sort of makes sense for us.